So I'll start myself, introduce myself. My name is Amit Levy. I'm Executive Vice President of Sales and Growth Strategy at Made4Net. So Made4Net is a supply chain execution, specifically warehouse management, some transportation, labor management. We're one of the leading players in this space. And was the Magic Quadrant, Gartner Magic Quadrant for the past 10 years. A global player, headquartered here in the U.S. Mostly serve the mid to high-end market, and appreciate the opportunity to speak here today. I'll let my colleagues introduce themselves. Roy?
Hey everybody, so first and foremost, thank you Amit and our partners and friends at Made4Net for sharing this stage and inviting us. I'm Roy Gherman. I'm the CEO and co-founder of Flymingo. Throughout my 27 years of career, I've focused on command and control systems, CNCs and MNCs. So basically fast tracking technology into end user applications, all of them around monitoring, control, and tracking, and leading to the foundation of Flymingo, which we'll have the opportunity to tell later. Thanks, guys.
Hamid?
Thank you, Amit and Roy. Amit Matazeri. I'm responsible for the software engineering and AI teams within Locus Robotics. And Locus provides automated mobile robots. Here, let me just walk a little bit so that it's not picked up by the speaker. Locus Robotics provides autonomous mobile robots. We have the biggest fleet of autonomous mobile robots deployed in the warehouses. They provide significant improvement for productivity. We'll talk about it later on. And I'm really glad to be here. Thank you very much. Back to you.
All right, folks. So, by the way, if there's any challenges in hearing us, and the microphone is further from our, so just let us know. So, I'm going to start this presentation today by giving you a little bit of a background or how I see and how the market sees AI, and slightly kind of lead way into presenting some technologies that we work with and what we've done in the AI space within supply chain, within the warehouse. Have Roy and Hamid join the presentation. So to start off with, this is a statement that Google's CEO has provided to the investors back in Q4 of 2024, and mentioning that 25% of labor, 25% of the code that's written by Google is done by AI. And everybody talks about AI. Everybody knows AI. I think most of us, for the most part, have the experience with ChatGPT or Gemini, and this is what's called LLM and generic AI. We want to talk about how AI impacts our life and how AI impacts labor in the future, because that is something that will be a game changer. My goal today is to take you to kind of a journey in the mindset and take you through a different way of thinking. With the main goal or main objective is to show how it's going to change our life. When you think about the AI, it seems like many people see it as just another step in the evolvement of technology. You look into history, the Industrial Revolution, the evolvement of the telephone, the computer, the internet, and so on. So this AI is just another thing. Is that really the case? So I'll give you a different perspective to it, and you make the judgment. But imagine that we're sitting now in the 19th century, and we're in a convention or a trade show, and we're horses, right? So horses, back in the 19th century, that was the main transportation. And then Mercedes introduces the first automobile, and a 3/4 of a horsepower engine that's on wheels and can be used as a mobile device. And the horses sit in this presentation and they ask themselves, well, what's going to happen with this thing? I mean, everything that we've been here in this world for the last 5,000 years. Every time that the human being introduced something new, it only benefited us, right? So there was the saddle, it was the cart, and so on. What's going to change? And the thing is that it did change. It did change, and if you look back into that time before the automobile, was introduced, there was about one horse for every 4 people. A little further, 100 years later, and probably today, there's a significant reduction in the number of horses in the world, and almost no horses other than just for fun and for riding them for sport, right? But they definitely are not used anymore for transportation. So this has been a massive change, and I'm using this example because I think that what happens with AI is kind of similar. So I'm going to share here 3 assumptions. The first assumption is that any job that can be done by Zoom or the equivalent to Zoom can be replaced, and AI will do a better job. And I'm sure you guys can agree to that. And it could be as simple as a legal job like a lawyer or a doctor or a psychologist, but it could also be other areas of expertise. Oh, the second point is that employees will replace people with AI if it benefits the business. If it benefits the business and if it will save them money. And then the third point is that within 5 to 10 years, AI will be better than people. As a matter of fact, it's already existing right now. AI in some areas is doing a better job than people. Look at this chart, and this is something I'm going to talk a little bit about this, how technology, made progress and kind of overlaps with human capabilities. And Hamid is going to talk about this a little bit further in his presentation as well. He'll come back to this slide and I'll remind you about this. But when you look throughout time, right? So you can see that technology has evolved, and it is slowly or not slowly taking over a lot of things that we do. Back in the back in the Industrial Revolution, there was a saying that any job that can be done by a machine and be replaced, or people can be replaced by a machine, will save cost and will save labor and so on. But we always, as human beings, we always had our mind, our intelligence, something, our brain, something that we can use as an advantage of machine. Now this is changing. So you're looking now at an era where we're challenged by computers, by AI, in being able to use our main competitive edge, right, which is our mind. The AI engine, and I know I'm not talking about warehouse and supply chain. I'll get there in a second. I'm just kind of warming up here and giving some different ways of thinking about this. But the whole concept of AI training, you can see how it evolves three times. So if you go back to 2018, where GPT-1 was introduced, the amount of parameters that was used in order to train the engine was about 117 million. Go forward 1 year or 2 years, right? We're talking about an increase of 10 times. You go back to the next generation of GPT-3, you're talking about 100 times more parameters that are training that engine, and so on and so forth. So this is massive numbers from a training perspective of that AI engine. And we'll get to a couple of more examples of where it's implemented and how it is, how it's used in real life. This is a graph that is showing a response of people that were asked, researchers that were asked, how is AI going to be accelerated throughout time, and when are we going to get to, to a point where it's going to take a much stronger presence in our life. And when you look at the numbers, 6 years ago, people were talking about a range of about 50 years that it's going to take to get there. Then the model changed a little bit, and ChatGPT 3 came out, and they suddenly changed the numbers, and they thought, okay, it's not going to take 50 years, it's going to take 34 years. And then another progress was made, and so on, and that time continues to go down. So ultimately, we're talking about the artificial intelligence taking a much stronger position in our life within the next few years. Could be another 2-3 years, could be another 5 years, but we're not talking about 50 years down the road. Autonomous cars, right? I think everybody knows that there's a company called Waymo, if I'm not mistaken the name, in San Francisco. They've introduced the facts that are shown here on the left side, 20 million miles with 70% less accident. From a training perspective, think about this. It takes to train an AI model to drive an autonomous car what a typical driver would gain in about 50 years. So this now is, we're going to talk a little bit later about the robots in the warehouse. This is a massive improvement and advance in technology. And I'll run this short video, which is going to show you in the last 10 years, three points in time of how robotics, this is a robotic championship by Boston Dynamics that was introduced. So you can see the evolvement of how those robots make progress in time. So this is 2015, right? That's how robots were in 2015. Now we're transitioning to 2021. So you can see a whole different set of skills and capabilities. Now, where I'm going with this is that this is not about the mechanics. This is about the intelligence. This is about the AI, about the engine, the brain behind those robots. Because the mechanics is basically the same mechanics. Now, we're going to transition to 2024, which is really where we're at today, and you probably walk the floor, you see this all over the place. All right, so 2-3 more slides, and I'll hand it over to my colleagues here. AI in supply chain, AI in warehousing. We as a warehouse management system, we're doing a lot of things in AI, specifically in LLM, so incorporating language into our platform, into our product. Large language models that are used in order to process data. The classic example that I'm going to share with you, one of few that we've implemented, is using vision. So what I did here, and just to make a point and to show you how we're doing this in our technology, is that I took this image from Google and I uploaded it into ChatGPT, and I asked ChatGPT, show me or tell me what do you see in the picture, right? So it created a complete analysis of what it's seeing in a matter of seconds, identifying that this is a box of strawberries, right? That that has mold on one of those strawberries, as you can see. By the way, I'm trying to pretend that I'm a QC guy, right? So within the warehouse, we're processing product, we're receiving, we're looking into it. In this specific case, if we're a produce distributor, and ChatGPT and the AI engine can see exactly what's on that product and what the problem is, what the potential risks are. And then the following analysis is that it provides all the characteristics and all the parameters that it sees here. It talks about storage standards, different type of restrictions and preventions of spoilage and so on. Things that we need to do and handle as part of the product that we're looking at, as part of what it analyzes from the picture itself. And this is, this is something that you incorporate into a system, and instead of a person identifying it, you let the AI engine do all the work of analyzing all these parameters, flow into the QC model, and the product in this specific case, since it's damaged, it's not good, can't distribute it to stores, so we're going to put it away into a specific location in the warehouse. I'll finish up with this statement that was made by Warren Bennis. I think it's pretty self-explanatory. The future warehouse will have a person or a man and a dog. The man will be there to feed the dog. The dog is going to be there to make sure that the person doesn't touch the machines. This is real life. This is where we're heading. You're going to see this coming in the next few years, in the warehouses and in other supply chain entities that we work with, manufacturing and so on. Roy, come on and step in and talk about Flymingo.
Thanks. So hi guys, again, super excited to be here. Let me share a bit about Flymingo. So we're an AI vision company, and what we provide to our customers is vision-based digital twins that allow them to reach an unprecedented level of monitoring control over their operations in real time. Not only that, or more than that, they reach very high levels, I would say extreme levels of data integrity and precision, both in real time and historically. Okay, thanks. Thanks. Can you hear me now? Better? All right, super cool. Cool. Right, here's how it works. So basically what we do, we connect to the existing camera system. We don't have any prerequisite for the type of camera, the angles, whatever. One camera or 400 cameras, we can connect them to them all, and then we connect to the WMS. We use our own API, so it's an easy leap. And what we do basically, we fuse them both. So in a sense, every data point in the WMS has a correlating visual, and every visual has a correlating data point over the WMS. After fusing them together comes a secret sauce. So we create context. How do we do that? So everything that you're seeing here, by the way, that's Coca-Cola IO. We'll talk about it in a second. But everything that you see here for us is an object. So people, pictures, palettes, cases, for us, everything in this universe is objects. We track them all. We track them all in real time. Whatever you're seeing in the frame, and more than that, we hand them over from one camera to the other. So if you have neighboring cameras, we hand them over. So we create a kind of a monitoring solution that creates context over the entire warehouse. And obviously we see all the parameters. How do you utilize the workforce? How do you pick accuracies? Are you picking for the right location, wrong location? How are you sending it out? This is a manual operation. We do the same with automated operations. And whenever we find a mismatch or something that the client defines as an alert situation, then we alert. So we've taken all of that and squeezed that entire operational universe into a digital twin. So for the first time, the entire operation, everything that you see in your warehouse is squeezed into one digital twin. We'll have an opportunity to say that in a second. Everything is under one side. Now, keep in mind, our system is an alerting system. It's a proactive system. It will send you alerts to different applications and different interfaces, whatever you choose. But if you want to see your operation in real time, this is the best way to do it. And you have everything there under one roof. So your visuals are there. You don't need to access your NVR or whatever vision system that you have there. Your alerts are there, and they're tied to a location and to a map. And every insight and data that we have, you're able to reach through it. So utilization, etc., and space, all of it is under one roof. This is actually how it looks, right? So either in real time or historically, you're able to see everything that happened inside your warehouse. So, and through our agent, our AI agent, you're also able to ask or communicate with your warehouse. And that creates context on maps. So you can search and figure out what happened to that shipment, what happened to that box, who's working, where am I seeing whatever I'm seeing wrong, or any data that you want to search about your operation is available for you right there in real time and historically, obviously. So we're creating value to our customers across the board, from the operational level, where shift managers, facility managers receive alerts and visuals on a daily basis. Well, a few tens of times on a daily basis. We'll share some numbers soon. And they get it all in context, specific actions, able to monitor everything that they're looking for up to the C-suite, where they can monitor the health of the facilities, see multiple facilities, see workforce, see how they're meeting, the waves that they have and everything that they're looking for at a more higher level of data. So one question I always get asked is, how many cameras do you need to start working with Flymingo? So you don't. You can actually start working with us even if you don't have cameras. So it's like walking into a kitchen and being blindfolded. You kind of know the space. You kind of know that if it's cold, it's probably the refrigerator. If it's hot, then you probably touch the stove, and so forth and on and on. So for us, it's mostly the same. So even without cameras, you're still able to get a lot of value from us using our AI and dashboards, and also our agent. So monitoring workforce utilization, pick and pack, accuracies, velocities, highlighting SOP deviations, etc., etc. Here's a case study, Coca-Cola IL. So Coca-Cola came to us a year back on our first deployment with them. We did 5 deployments of this past year, and looking forward to doing 25 more in the next couple of years. And they have a really fast moving warehouse. So the set of warehouses that they do, they're very, very, very fast. They're scanless. And what Coke needed from us is to take care of the quality. What we did with them, we monitored that operation, that video that you just saw, and we provide for each warehouse 13,000 alerts per year. Okay, every deviation, every mispick, every SOP deviation got alerted. So we eliminated 90% of the customer complaints. 90% of them just were slashed out. And that also impacted the dwelling time of trucks and deliveries. So improved the dwelling time and reduced it by 70%. And we also, since you make less mistakes, so you're way more efficient, we got off about 2 hours of the working day because they were reaching their quota way earlier. So they saw also 8% productivity increase. And, the most important metric, the savings, I can't share exactly the savings, but it's way more than 500,000 per site per year. So that's the impact we had there. So we have multiple solutions. It's it's very easy to deploy in any situation where you're a manufacturer, 3PL, distributor, whether it's pick and packing, yard management, or even replenishment solutions. And this is something to create our partnership with Made for Net here. This is a mutual customer that we have, Abilene, which are great partners. And with them, it's been a real huge success story. Going from reports September last year, the different facilities, 7 cameras, up to this new launch facility that is launching right now, where they went ballistic with it and probably reaching about 400 cameras. Is extremely happy with what we're doing for them. Thank you very much.
Thank you. Thanks, Roy. Just to add some color to what Roy said on the computer vision solution. The key here is in the integration to the WMS data, which feeds in real time every single transaction that we define as an event. And based on the camera image capture, it detects exceptions, right? So just to give you an example, I'm supposed as the WMS instructs me to take a pallet and load it to door number 6 because that's the truck it's supposed to go on. And me as a forklift driver, I go on, do that job, scan the door, but for whatever reason, I either don't put it on the door on the truck or put it on a different truck that's just the next door. That's the challenge, right? So with the vision, you're able to track all that, save a lot of time in figuring out where did that mistake come from. Because what happens is the customers claim, right? They complain after the fact that they got the wrong pallet or that the pallet didn't get there. So this is how you are able to track or to control the processes to prevent the mistakes and bring more value in terms of time and cost. Amit?
Thank you very much, Amit. So I'm going to draw upon some of the slides that Amit and Roy talked about. And you know me, so I'm just going to bypass this. And in general, step back and say, how do we leverage AI in order to get warehouse excellence? And if you remember, Roy showed you a number of metrics where people measure how effective AI is in their work. So in general, what you want to think about is in terms of metrics. And the 5 most important metrics that you always hear from warehouse operators is maximizing throughput, minimizing cost per unit pick, minimizing cycle time, maximizing the number of SKUs that they can push through, and dealing with exceptions. So whenever you look at how AI can benefit warehouse operations, have those 5 things in mind. All of them are extremely important in warehouse operations. So that's one thing I wanted to talk about. The second thing to bring to your attention was the slide that Amit showed, where you saw overlapping human ability and AI ability. And we are at a stage where there's a lot of overlap. So we are looking at AI augmented human operations. And I think what you saw from Roy also indicated how AI can augment human beings in dealing with better operations. The same is true for robots, and we'll talk about them in a second. The third thing I wanted to talk to you about was to think about agents. You hear about agentic AI, and while it's something new, that phraseology, but it really goes back to the research done by a number of researchers, including Professor Stewart Russell at UC Berkeley. He just won an award this year in excellence in AI, and Peter Norvig, where they looked at AI systems in 2 dimensions. One was, can it understand human being, do a conversation, apply rules of logic as put together by logicians like Wittgenstein, and then expand that to today into probabilistic reasoning. That's one dimension. The second dimension is that can they interact with their environment? So the first dimension, you have the Turing test. The second dimension is, can you interact with the environment and make changes to the environment in order to improve some type of operation? And that one is the extended Turing test. And the systems that can do that, they called intelligent agents. And agentic AI actually generalizes that with environments that are not only physical, you need to have context. We talked about context. You need to have context in that environment, but it could be a complete environment. So with that in mind, AMRs are actually intelligent agents that interact with their environment based on having ability to perceive their environment. They sort of create and pursue goals. If you look at agentic AI, every agentic AI should be able to create and pursue a goal, and needs to do that autonomously without human interaction. And it needs to adapt to the changes in the environment that you didn't expect. And on top of that, you need to be able to do logical reasoning and things of that nature. So with that said, I also want to bring to your attention one more thing. When you deal with environments when there is collaboration between robots and human beings, like in an environment where you have autonomous cars driving, or in a warehouse, you really need to have what is called explainable AI. You need to be able to reason as to why something happened. You just can't say, I ran into something, oops, I hadn't trained my system on that. Because there is no guarantee that if you train it on that set of circumstances, you wouldn't do it under a different light condition or under a different topology. So you'll see a lot in autonomous vehicles and also in AMRs that we rely at the level of, for AI, explainable AI at the level of the box. So with that said, I want to look at a number of cases. It's a complex thing to deal with the environment. So if you have an intelligent agent like a bot, there are multiple things that happen that you have to take care of. Some examples are here. This one is, a bot is moving along and needs to go to a place for a pick. And then there's another bot on its way. So it needs to know enough about its environment to see if he can maneuver around it and whether if there is any safety zone issue, any collision problem, and go to where it needs to go. And then the second bot may have to do the same thing. Another example is some of the lanes in a warehouse may be two-way passing. Now you have situations where bots are approaching each other, but they have a velocity. And how do you get the kinematics involved in it? How do you apply AI in order to navigate that? You may have cases where you, as you're planning, as the bot is planning where to go, it discovers there is a better path to go than the straight intuitive path. And so it should be able to autonomously pick that up. You may have cases where you have to maneuver around objects that you don't know about. You know a little bit about the other bots of your type, but you don't know anything about the other things that may show up. Now, finally, there could be cases where the path that you've planned as a bot, as an autonomous bot, is blocked. You need to be able to handle that. So there is a number of really, and this is just the tip of the iceberg, there's a number of really complexities in autonomously navigating. And Roy mentioned that right now a lot of autonomous vehicles have 20 million miles of data gathered. We have 150 million miles of data gathered on autonomously navigating warehouses. So the other aspect of having intelligent agents when you apply them to the warehouses is the ability to actually add quickly extra agents and subtract from it. In particular, in the warehouse environment, there are seasonalities where they need extra bots. They call us and say they need extra bots. The key thing, and you can see it here in this video, is to be able to deploy a physical, intelligent bot quickly. And typically you can do that with our bots in less than 5 minutes, and most of it is really taking the bot out of the packaging and then pressing 2 buttons in its way, and you've added one more bot to your system, and you can subtract just as easily. The other part of what you deal with in the warehouse operation is to look at having multiple bots all supported with one type of AI stack. And that's really important because there are different bots that attend to different things in terms of load carrying capacity, in terms of point-to-point versus pick versus put-away type operations. And in order to have a manageable system, you really need to have a foundational system in place that can attend to all of them. Here's an example of scale that sometimes you encounter in warehouses. This is an actual warehouse operation. This is not a simulation. We have a tool that captures where the bots are at any point in time. And this is a customer we have that has over 700 bots, 700 intelligent agents moving around, and it processes about 200,000 units. And it's a customer that is in the footwear and apparel, and these bots do put away, picking, and counting of inventory. So really important to be able to handle the scale. And finally, when you look at what you get from all of this, again, remember that we talked about the 5 type criteria, and I sort of built this, and you can see when you apply intelligent agents like AMRs, the results are amazing. You get about 2 to 3 times boost in productivity. You have to maximize productivity. You get 50% reduction in cycle time. Cycle time is the time that it takes to fulfill an order. So that's a huge amount of reduction in cycle time. You get about 70%, about 33% decrease in cost per pick. So you reduce your cost per pick by 2/3. That's huge. Basically, if you talk to a lot of warehouse operators and they say, I can cut 1 second off of your operations, that results in about more than $1 million of savings. Just think about what 2/3 increase in cost per pick means. At the same time, these are collaborative bots. Remember, they are augmenting human abilities. It would be of no use if it takes a lot of time for humans to kind of learn how to deal with it. But these ones would take very little time to learn. Basically everybody could be trained on it within 20 minutes, 30 minutes, if not an hour. So it's a 90% decrease in training time compared to other systems. And it actually makes human life better because the average worker in a manual warehouse walks about 15 miles. They're really in good shape, but they're beat when they go home. With applying intelligent agents like these AMRs, you reduce that by about 70%. So thank you very much for your attention. It's really important to consider the application of AI in warehouse automation because we're getting more and more into a world where we would be really impacting warehouse operations. So with that, I stop and we can go to questions. Thank you.
Thank you very much, Amit. Folks, I'd like to wrap it up. You see all this technology is evolving. We're making progress on a lot of fronts, both on our personal life, but also in business. We see how automation, AI-driven automation, can boost productivity, improve our day-to-day operations, save money to our employers, and bring more value to the organization, which is fantastic. At the end of the day, it's going to be mostly around labor savings. So thank you very much for your time. Appreciate it. If anyone has any questions, we're happy to answer.
Thank you for attending our session. AI-driven automation is no longer a futuristic concept. It's transforming warehouse operations today. By optimizing key metrics like throughput, cost per pick, cycle time, order processing capacity, and exception handling, AI is helping warehouses achieve peak efficiency while reducing costs. As AI continues to reshape the industry, the question isn't whether to adopt it, but how to use it to your advantage. Are you making the most of AI in your warehouse? We're here to help ensure you do. Get in touch with Made4Net, Flymingo, Locus Robotics.